Machining trends have evolved dramatically over the last 2 years. Now this video we're going to show you a 60% reduction in cycle time and also the 3 main things you need to consider when buying your next machine. So Adrian, you're from Ceratizit and you manufacture tooling. So I'm here talking and hear so often lighter speeds and feeds, not the deeper cuts. So what's this evolution that's happened?
It's an evolution that's come about in parallel really with the machine tools, the cutting tools and the software that's used to program the machines.
So you've got the trio, the machine tool, the cutting tools and the software. So what's changed?
Essentially the methodology's changed. The machines these days are much faster, much lighter, they have much more processing power than they used to have. So the development of the cutting tools has to work in parallel with that development of the machine tool, which is obviously also in line with the development of the software.
So before we get on to the machine tool and the software, what development is this? What is it you are looking to create with your tooling that can help reduce those cycle times?
Well, essentially what we're trying to do is we're trying to maximize this processing power and this ability of the machine to run faster. So you've got now the ability to be able to run at very, very high cutting data, but with very, very light depths of cut. So you end up with a very, very light radial depth of cut, but quite a deep axial cut. So metal removal rates are dramatically higher.
So what is it that Ceratizit are doing to kind of complement this machine and this actual example here?
Well, what we've done here with this example is try to demonstrate the effectiveness of circular line CCR cutters, which are effectively using a trochoidal strategy, a trochoidal milling strategy that enables you to run with very, very large axial depth of cut, but a very, very light radial width of cut, but at very, very high speed and feed.
And so how does the Vulcan machine benefit your range of tools?
In order to be able to utilize this kind of tooling, you need a machine with the processing power that's able to drive very, very large NC programs. The code that's being generated by the software house outputs a very, very large program with a lot of data. And in order to be able to maximize and utilize that data, you need a machine with the relevant NC control unit that can process that data.
So now I'm going to speak to Steve more about the machine, but then we'll come back and see more about this 60% reduction in cycle time.
Okay.
The 610L is one of our most competitive machine tools within our portfolio. So the Vulcan range, what you've seen there is a 12K spindle, 20 bar through spindle coolant, swarf management included, obviously for swarf evacuation. And the machine tool really is an entry-level machine into the market. So if people are looking for their first CNC machine tool or adding additional capacity, it's the perfect fit. You know, it's a less than 50K machine. And again, compared to what you would experience in a machine tool 2 years ago, it has all the specification that a customer requires for today. So the machine tool again was designed and built around to suit all applications. So generally with aluminium you need high spindle speed, with tool steels you need high power. So we've generated that machine to accomplish both features. So we have a 12,000 RPM spindle, we have the 23 bar through spindle coolant, and we have a high power torque spindle on there. Again, all for less than 50K.
Right, so a 60% reduction in cycle time. How have you done it? Show me the steps.
Essentially what we've done is taken this, which is just a demo part, and what we did is we manufactured it the first time round using the kind of conventional methods that everybody would use, and then updated that to using the new CCR cutters and the trochoidal strategies. That effectively took the cycle time of this part from over 22 minutes to just over 8 minutes. So somewhere around about a 60-odd% reduction in cycle time. So
where's the technology? Where's that reduction? How physically is it happening?
It's basically in the design of the cutter. The tools themselves are designed with an extremely strong core, but also with a chip breaker that runs up a helical chip breaker that runs up the flutes that effectively breaks the chips down into very, very small manageable sizes so that they're easily evacuated from the part.
How does the Vulcan range then benefit? What's the power behind this machine that helps your tools?
The power behind the machine is essentially, as I mentioned earlier, in the processing of the machine, the processing power of that control. We don't need huge amounts of spindle speeds and huge amounts of power on the machine anymore because we're running at very, very light radial depths of cut. What we need is the processing power of the control to be able to manage those tools.
So the Vulcan range is a volume seller for us. So we have a flurry of machines in. Literally we've turned these around in 24 hours. So order one day and we can deliver the next.